Lesson 2-3 is solving two-step equations. First thing I'd like to do is review order of operations and inverse operations. So order of operations, remember the first step is to look at what's in our grouping symbols. And sometimes we have brackets with parentheses inside. Sometimes we just have the parentheses. Step 2 is to solve the exponents. Step 3 is multiplication and division. From left to right. And step 4 is addition and subtraction from left to right. Which is quite fondly referred to as "please excuse my dear Aunt Sally." Next we have inverse operations. And inverse is synonymous with opposite. So it's an opposite operation. It undoes the operation that has been performed. So first, the inverse operation of addition is subtraction. And I've drawn this double-headed arrow because they are each other's inverse. So the inverse of addition is subtraction, the inverse of subtraction is addition. And multiplication's inverse is division, and division's inverse is multiplication. And we're going to use the order of operations and inverse operations to solve our two-step equations. So first we have 7x plus 12 equals 33. I'm going to show you a method called the box method. And this method just shows how we undo the order of operations. So first, I have x equals, and since I have 3 separate terms up here, I need 3 boxes. And the first thing I want to do is look and see what operation has been performed on the x. Well, it was multiplied by 7. And then the next operation in order of operations would be to add 12. And once those two operations were performed, the answer was 33, so that goes in the first box, or the last box. Now we use our inverse operations to undo this. So the opposite of adding 12 is subtract 12. So we're undoing the order of operations. So 33 minus 12 is 21, and the opposite or inverse operation of multiplying by 7 is dividing by 7. So ultimately 21 divided by 7, x equals 3. And that's our answer. Let's try another one. So again, I look at this and I set it up. I've got 3 terms, so I end up putting 3 boxes, and I'm solving for z. And the first operation according to order of operations that's been performed on the z was divide by 3. And then subtract 8. And that resulted in the answer being 5. Well, now I reverse that. And I end up saying, well, the opposite of subtracting 8 would be to add it. 5 plus 8 is 13. And the opposite of dividing by 3 is multiplying by 3. So z is ultimately 39. And again, this method is really to show you the method, what's going on when we're actually solving these, because I think sometimes we get just so hung up on, oh, this is the process, this is the process, this is the process, and I want you to see why we actually have the process. Let's try one more. So we have y equals, and then this one looks a little bit different, but I still want to do it the same way. The first operation that's happened to the y is that it's been multiplied by a negative 6. And then this 7 is, I don't look at this and say, oh, I have to add 7 because there's a subtraction sign. You might want to think of this as 0 plus 7. So that lets me know, oh, 7 was actually added. And the result was 55. So now I undo this and I subtract 7. So 55 subtract 7 is 48. And then the inverse operation of multiplying by negative 6 is dividing by negative 6. 48 divided by negative 6 is negative 8. So y would equal negative 8. So let's go ahead and try this without the box method, because let's face it, that's how you have been taught in the past, and I want to go ahead and be consistent with that. I just wanted to introduce the other method to show you what's going on. So if we think about this, thinking back to the box method, the first operation was divide by 3, subtract 11. So we undo this and we add 11 for our first step. So negative 25 plus 11 is negative 14 equals r minus 3. And then we have to undo the division, so we multiply both sides by 3. That's not a negative 3, that's positive 3. So 3 times negative 14, r equals, we know it's a negative, and it's 42. R equals negative 42. And I do expect you to show me your work. You can either show it to me vertically, which is the way that I believe you were probably taught how to show it, or some people, especially if you maybe are transferring from a different school, were shown the horizontal way. And let me just show this off to the side. If I had negative 25 equals r divided by 3 minus 11, some people start out like this. Negative 25 plus 11 equals r over 3 minus 11 plus 11. So this is just the horizontal method. We're doing the same thing. We end up with negative 14 equals r over 3. And then they would just show the multiplication basically the same way. So either with multiplying in parentheses or multiplying with the little star. Let's try a few more. So first was multiplication, then was addition. So we're going to subtract to undo the addition. So 6r equals negative 6. Divide by the 6 because that undoes the multiplication. R equals negative 1. Same thing here. We had division then addition. So we'll undo the addition to get t over 2 equals 8. Undo the division by multiplying, and t equals 16. These look a little bit different right here. I cannot break out this quantity until I eliminate the denominator. So this is, again, a little bit different. When you have an expression over a denominator, you want to first eliminate the denominator by multiplying, because really you're undoing the division. So 3 times 21 is 63 equals a minus 4. And now this is just a one-step equation. We're going to add 4. So 67 equals the a. And then this one, multiply by 7. So c plus 8 equals 98. And subtract the 8. So c equals 90. Okay, that's it for the notes. Tomorrow when you get here, I'm going to do some warm-up problems just to make sure that you have this. I want you to be able to try it with your AB partner, and I want you to try it on your own. And then I will let you go ahead and get started on the assignment. For those of you that want to start ahead, I'm still going to have you work with the class tomorrow. But this is lesson 2.3. And it's page 94 to 96, problems 2 to 40 even.